Hello and welcome. Before we solve this equation, let us quickly list the laws of logarithm. Now we know that log A multiplied by B is equal to log A plus log B. Log A divided by B is equal to log A minus log B. Log A to the power B is equal to B multiplied by log A. And lastly, we know that when we have log to base A of B being equal to X, and this is the same as writing A to the power X is equal to B. Now let us look at this equation. We have log to base 3 of 9x. Remember that this is log to base 3 of 9 times x. So from this law, we can write this as log to base 3 of 9 plus log to base 3 of x. Then plus log to base 3 of x is equal to 4. Now notice that you have log to base 3 of x and log to base 3 of x. So two of the same thing. So we have log to base 3 of 9 plus 2 times log to base 3 of x is equal to 4. But remember that 9 is equal to 3 squared. So this is log to base 3 of 3 squared plus 2 times log to base 3 of x is equal to 4. Now from the third law, you know that we can write this as 2 times log to base 3 of 3 plus 2 times log to base 3 of x is equal to 4. Now look at this. We have log to base 3 of 3. And of course, I forgot to add it here. Log to base A of A is equal to 1. So this is equal to 2 times 1. So here we have 2 plus 2 times log to base 3 of x is equal to 4. Now from this line, we can write 2 times log to base 3 of x is equal to 4 minus 2. So we have that 2 times log to base 3 of x is equal to 2. And of course, we can divide both sides by 2. When we do that, this takes care of that. And we have that log to base 3 of x is equal to 1. Now look at the last line. We have log to base A of B is equal to x. So this simply means that 3 raised to power 1 is equal to x. That is 3 raised to power 1 is equal to x, or 3 is equal to x. So the solution to this equation is x is equal to 3. But there's a second approach that we can use to solve this equation. Now, once more from the first law, you know that we can combine these two as log to base 3 of 9x multiplied by x is equal to 4. That is from the first law. And when we do this, you can see that from the last line, 3 to the 4th power is equal to 9x times x, or 9x squared. So we have that 3 to the 4th power is equal to 9x squared. And from here, we simply have that x squared is equal to 3 to the 4th power divided by 9. But let us remember that 9 is 3 to the 2nd power. And from our laws of indices, we have that A raised to power m divided by a raised to power n is equal to a raised to power m minus n. So this is simply equal to 3 raised to power 4 minus 2. So we have that x squared is equal to 3 raised to power 4 minus 2 is 2. So x squared is equal to 3 squared. So that simply means that x is equal to 3. And you can see that we arrived once more at the same answer. To solve this equation, let us recall the law of logarithm that says that log A plus log B is equal to log A multiplied by B. Now, applying this law to this equation where A is x and B is x plus 4, we know that log₂ base 2 of x multiplied by x plus 4 is equal to 5. Now, having gotten to this point, let us also remember that when we have log₂ base a of b being equal to y, that this simply means that a to the power y is equal to b. That is, a to the power y is equal to b. Now, with this in mind, we can rewrite this as 2 to the power 5 is equal to x multiplied by x plus 4. That is, 2 to the 5th power is equal to x multiplied by x plus 4. Of course, we know that 2 to the 5th power is 32. So this is equal to, opening this bracket, we have x times x, and that is x squared plus 4 times x, which is 4x. And rearranging this quadratic equation, we have x squared plus 4x minus 32 is equal to 0. We can factorize this equation, and since the coefficient of x squared is 1, we can do this. Now the question is, what are the factors of minus 32 that will add up to plus 4? And of course, we have 8 and minus 4, because 8 multiplied by minus 4 is equal to minus 32, while 8 plus minus 4 is equal to 4. So what we do is we have x plus 8 and x minus 4, and this is equal to 0. So from here we have that x plus 8 is equal to 0, or x minus 4 is equal to 0, and hence x is equal to minus 8 or plus 4. So now we have two values for x, minus 8 and plus 4. Now let us go back to the equation. We have log₂ base 2 of x, and you know that we cannot have the logarithm of a negative number. So this answer is not acceptable. The only correct answer to this equation is x equal to plus 4. Now to check our answer, let us substitute x equal to plus 4 into this equation and see if we get 5. So we have log₂ base 2 of 4 plus log₂ base 2 of 4 plus 4 is 8 is equal to 5. Now 4 is 2 squared, so this is log₂ base 2 of 2 squared plus log₂ base 2 of 8 is 2 cubed. That is 2 cubed. And we are testing to know if this is equal to 5. Now at this point, let us remember the law of logarithm that says that if we have log₂ base a of b to the power b, that this can be written as b multiplied by log₂ base a of b. So we can bring this 2 down and we can bring this 3 down to have that 2 times log₂ base 2 of 2 plus 3 times log₂ base 2 of 2 is equal to 5. Next, let us recall that when we have log₂ base b of b, that this is equal to 1. And here we have log to base 2 of 2, and we have log to base 2 of 2. So this is simply 2 times 1 plus 3 times 1 is equal to 5. This is 2 plus 3 is equal to 5. And of course, 2 plus 3 is equal to 5. So we have that the left-hand side is equal to the right-hand side. And thus, this answer is correct. On looking at this equation, you will immediately notice that the two logarithms are in different bases. This is in base 2 and this is in base 4. So the very first step to solving this equation is to make sure that the two logarithms are expressed in the same base. Now, since 4 is a multiple of 2, let us change this to base 2. And to do that, we use our change of base formula. And this is how it's applied. This now becomes log to base 2 of x divided by log to base 2 of 4. So in doing this, we have changed the base of this logarithm from base 4 to base 2 plus log to base 2 of x, and everything still remains equal to 6. Now we can evaluate this quantity. So if log to base 2 of 4 is equal to y, this simply means that 2 raised to power y is equal to 4. Notice the anti-clockwise motion. So we have 2 raised to power y is equal to 4. And this is a very simple equation for us to solve, because we know that 4 is equal to 2 squared. And since we have 2 here and 2 here, that tells us that y is equal to 2. So we have log to base 2 of x divided by 2 plus log to base 2 of x is equal to 6. Or this can be written as half times log to base 2 of x plus log to base 2 of x is equal to 6. Now we have log to base 2 of x in both terms, so we can factor that out. So we have that log to base 2 of x into half plus 1 is equal to 6. Now half plus 1 is equal to 3 over 2. So we have that 3 over 2 multiplied by log to base 2 of x is equal to 6. Next, we multiply both sides of this equation by 2 and we divide by 3. So we have that 2 over 3 times 3 over 2 times log to base 2 of x is equal to 2 over 3 times 6. This leaves that as 1, and 6 divided by 3 is 2, so this is equal to 4. So we have that log to base 2 of x is equal to 4. Now, once more, this statement simply means that 2 raised to power 4 is equal to x. So this means that 2 raised to power 4 is equal to x. And of course, 2 raised to power 4 is 2 times 2 times 2 times 2 is equal to x. That is 4 times 4, and that is 16 is equal to x. So we have that the value of x that satisfies this equation is equal to 16. I hope you've learned something. At least I know you must have learned how to change bases from this exercise. Remember to subscribe, like, and share. Hello and welcome. In today's tutorial, we have a logarithmic equation in two different bases. But to solve this problem, we need to work in the same base. So since 9 is a multiple of 3, let us change the right-hand side from base 9 to base 3 using our change of base formula. When we do that, we have that this becomes log to base 3, that is the new base of 4x plus 5 divided by log to base 3 of 9. But then we know that 9 is equal to 3 squared. So let us write this as 3 squared. Now at this point, let us recall the power law of logarithms. That is that law that says that log A raised to power b is equal to b multiplied by log a. With this law, we can simply bring down these two to multiply. When we do that, we have 2 times log to base 3 of 3. But then also, when you look at this and remember that log to base a of a is equal to 1, you notice that the denominator is simply 2 times 1, which of course is equal to 2. So we can write this original equation as log to base 3 of 3x plus 2 is equal to half times log to base 3 of 4x plus 5. Now let us multiply through this equation by 2. When we do that, we have 2 times log to base 3 of 3x plus 2 is equal to log to base 3 of 4x plus 5. Once more, remember the power law of logarithms. So that means that we can write this left-hand side as log to base 3 of 3x plus 2 squared is equal to log to base 3 of 4x plus 5. Now we have log to base 3 of this quantity is equal to log to base 3 of this quantity. So that simply means that 3x plus 2 squared is equal to 4x plus 5. Now let us expand the left-hand side. When we do that, we have 3x raised to power 2. That is 9x squared plus 2 times 3x times 2. That is 12x plus 2 raised to power 2, which is 4, is equal to 4x plus 5. Bringing all the terms over to the left-hand side, we have 9x squared plus 12x minus 4x plus 4 minus 5 is equal to 0. We have that 9x squared, 12x minus 4x is going to give us plus 8x. 4 minus 5 is going to give us minus 1, and this is equal to 0. Now we can factorize this quadratic equation, and to do that we simply multiply this term by this term. When we do that, we have minus 9x squared. Now the question becomes, are there factors of minus 9x squared that will add up to 8x? And of course, yes, there are, because we have 9x and minus x. Because you already know that 9x multiplied by minus x is going to give us minus 9x squared, while 9x added to minus x is going to give us plus 8x. So the next thing we do is replace plus 8x in this equation with these two factors. So we have 9x squared plus 9x minus x minus 1 is equal to 0. Now, when you look at these two terms, they have a common factor, which is 9x. 9x squared divided by 9x is x, and 9x divided by 9x is 1. Here we have minus 1. Minus x divided by minus 1 is x, and minus 1 divided by minus 1 is plus 1, and this is still equal to 0. We collect the factors. We have 9x minus 1 and x plus 1 to be equal to 0. And of course, from here we have that either 9x minus 1 is equal to 0 or x plus 1 is equal to 0. From here, we have that 9x is equal to 1 and x is equal to 1 over 9. Or from here, we have that x is equal to minus 1. So we have that x is equal to 1 over 9 or minus 1. Now, because of the negative sign, let us check this answer to make sure that it works. So substituting x for minus 1 in this equation, we have log to base 3 of 3 times minus 1 plus 2 is equal to log to base 9 of 4 times minus 1 plus 5. Now this is log to base 3 of minus 3 plus 2 is equal to log to base 9 of minus 4 plus 5. Here we have log to base 3 of minus 1 is equal to log to base 9 of 1. But we know that the logarithm of a negative number is undefined. So that means that x is equal to minus 1 is not acceptable. So the only right answer that we have is x equal to 1 over 9. When you look at the logarithmic equation on the board, you'll see that these two terms are alike, because here we have log to base 5 of 3 to the power 2x plus 6, and here we have log to base 5 of 3 to the power x. So the first step to solving this equation will be to group these two terms that are alike on one side of the equation. And when we do that, we have log to base 5 of 3 to the power 2x plus 6 minus log to base 5 of 3 to the power x is equal to 1. Now the next step is to remember that when we have log A minus log B, that this can be written as log A over B. So we can write this left hand side as log to base 5 of 3 to the power 2x plus 6 divided by 3 to the power x, and this is still equal to 1. Next, recall that when we have a statement like this, that is log to base A of B is equal to y, that it simply means that A to the power y is equal to B. Note the anti-clockwise movement. A to the power y is equal to B. So that means that 5 to the power 1 is equal to this quantity. That is 5 to the power 1 is equal to 3 to the power 2x plus 6 divided by 3 to the power x. Now, of course, from here, we can cross multiply. And when we do that, we have that 5 times 3 to the power x is equal to 3 to the power 2x plus 6. Let us rearrange this equation. We have 3 to the power 2x minus 5 times 3 to the power x plus 6 is equal to 0. Now, of course, you know that when we have 3 to the power 2x, this is the same as writing 3 to the power x squared, because when we have a to the power m to the power n, this is equal to a to the power m multiplied by n, and x times 2 is 2x. So this equation now becomes 3 to the power x squared minus 5 times 3 to the power x plus 6 is equal to 0. Here you can already see a quadratic equation in 3 to the power x, which we can solve. We can factorize this equation. All we have to do is to find the factors of 6 that add up to minus 5. And of course, those will be minus 2 and minus 3, because minus 2 times minus 3 is going to give us plus 6. And minus 2 plus minus 3 is going to give us minus 5. So factorizing this equation, we have 3 to the power x minus 2 multiplied by 3 to the power x minus 3 is equal to 0. From here, we have that 3 to the power x minus 2 is equal to 0, or 3 to the power x minus 3 is equal to 0. And 3 to the power x is equal to 2, or 3 to the power x is equal to 3. Of course, when we have an equation like this, the next thing we do is to take log of both sides. So we have that log₃ to the power x is equal to log₂. Or here, we can express this as 3 to the power 1. And from where we directly get that x is equal to 1, because since we have 3 here and 3 here, we can simply equate the exponents. Now for this, let us recall the power law of logarithms. That is that law that says that when we have log m to the power n, that this can be written as n, that is this exponent, times log m. So from here we have x times log₃ is equal to log₂. Dividing both sides by log₃, we have that x is equal to log₂ over log₃. And then you know that we can also write this as log₂ base 3 of 2. So now we found two values of x that satisfy this logarithmic equation. One is x equal to 1, and the other one is x is equal to log₂ base 3 of 2. Hello and welcome. In today's tutorial, we have a log equation in which the unknown x is in the base. Obviously, the first step to solving this equation would be to change the base. But then the question becomes, what base do we change to? Now, when you look at this number, this is number 4, 2 squared, and this is number 8, 2 cubed. So it would be best for us to change to base 2. So what we are going to do now is to change this from base 3x to base 2, and to change this from base 2x to base 2 using the change of base formula. And this is how we do it. We have log₂ base 2, that is the new base of the number 4, divided by log₂ base 2 of the old base 3x. And this is equal to log₂ base 2 of the number 8 divided by log₂ base 2 of the old base 2x. The next step to solving this equation will be to cross multiply. So we have that log₂ base 2 of 4 multiplied by log₂ base 2 of 2x is equal to log₂ base 2 of 8 multiplied by log₂ base 2 of 3x. But let us remember that 4 is 2 squared and 8 is 2 cubed. So we have that log₂ base 2 of 2 squared multiplied by log₂ base 2 of 2x is equal to log₂ base 2 of 2 cubed multiplied by log₂ base 2 of 3x. Now looking at this, let us recall the power law of logarithms, which states that log m raised to power n is equal to n multiplied by log m. So with this in mind, we have that we can bring these two down to multiply, and that gives us 2 times log₂ base 2 of 2 multiplied by log₂ base 2 of 2x is equal to 3 times log₂ base 2 of 2 multiplied by log₂ base 2 of 3x. But then we know that log to base 2 of 2 is 1. Log to base 2 of 2 is 1. So we have 2 times log to base 2 of 2x. That is 2 times log to base 2 of 2x is equal to 3 times log to base 2 of 3x. 3 times log to base 2 of 3x. Now, once more, let us look at the power law. We have 2 times log to base 2 of 2x. It is written in this form. So, of course, we know that we can write it in this form. And doing that, it becomes log to base 2 of 2x, 2 goes up, squared, is equal to log to base 2 of 3x, 3 goes up, cubed. Now, when we look at these two things, their logarithms are the same. So that simply means that 2x squared is equal to 3x cubed. From this, we have 4x squared is equal to 27x cubed. Now, from here, bringing all the terms over to the left-hand side, we have that 4x squared minus 27x cubed is equal to 0. We can factorize x squared out to give us 4 minus 27x is equal to 0. Now we have a product that is equal to 0. So it simply means that either x squared is equal to 0 or 4 minus 27x is equal to 0. This is a trivial solution. So from here we have that 4 is equal to 27x. And dividing both sides by 27, we have that x is equal to 4 over 27. And that is the value of x that satisfies this logarithmic equation. Hello and welcome. In today's tutorial, we are going to solve these two simultaneous log equations step by step. To begin, let us look at this quantity, that is log to base 9 of x. Applying the change of base formula for logarithms to this quantity, we can write this as log x divided by log 9. These two things are exactly the same. The only difference is that while this is in base 9, this is in base 10. Now, the next thing we do is to divide both the numerator and the denominator of this fraction by the same quantity, which is log x. Because you know that when we divide the numerator and the denominator of a fraction by the same quantity, we haven't changed that fraction in any way. So we have log x divided by log x over log 9 divided by log x. Now, log x divided by log x is 1. We can rewrite this denominator as log to base x of 9. Now, remember that we started with log to base 9 of x, but now we have ended at 1 over log to base x of 9. So we can generalize this by saying that if we have log to base a of b, that it must be equal to 1 over log to base b of a. And this is a relationship that is going to be very important for us in solving these two equations. Because when you look, you can see that we have log to base 9 of x, and here we have log to base x of 9. Here we have log to base y of 8, and here we have log to base 8 of y. So that simply means that, for instance, if we decide to call this a and to call this b, then this is going to be 1 over a, and this is going to be 1 over b. So we can rewrite these two equations as a plus b is equal to 2, and 1 over A plus 1 over B is equal to 8 over 3. Now we can solve these two equations for values of A and B. And then after we do that, we will now go back to these substitutions and get values for X and Y. Now to solve these two equations, let us start with the second equation. We can combine these two fractions into one single unit. How do we do that? A times 1 is A. We have plus B times 1 is B. A times B is AB, and this is equal to 8 over 3. Now the next thing we do is to cross multiply. So we have that 3 times A plus B is equal to 8 times AB. But let us come to the first equation. We have that A plus B is equal to 2. So this is equal to 2. And then from the first equation also, we have that A is equal to 2 minus B. So here where we have A, we can replace it with 2 minus B. So basically what we have is that 3 times 2, which is 6, is equal to 8 into A is now 2 minus B, and we have B. The next thing we do is, this is an even number and this is also an even number, so we can divide both sides of the equation by 2. So we have this over 2 and this over 2. Here we have 3 and here we have 4 into, let us open this bracket, 2 times B is 2B minus B times B is B squared. So we have that 3 is equal to 4 times 2B is 8B, and 4 times B squared is 4B squared. Rearranging this equation, we have that we can bring all the terms over to the left-hand side, and when we do that, we have that 4B squared minus 8B plus 3 is equal to 0. So now we have a quadratic equation in B which we can solve for values of B. And we can factorize this equation. How do we do that? We simply multiply this term by this term. 3 times 4B squared is going to give us 12B squared. Now we ask ourselves the question, what are the factors of 12B squared that will add up to minus 8B? And of course, those will be minus 6B and minus 2B, because minus 6B multiplied by minus 2B is going to give us plus 12B squared, while minus 6B added to minus 2B is going to give us minus 8B. So the next thing we do is to replace this quantity in this equation with these two quantities. And when we do that, we have 4B squared minus 2B minus 6B plus 3 is equal to 0. We can divide these two by 2B. So we have 2B. 4B squared divided by 2B is 2B. Minus 2B divided by 2B is minus 1. We can divide these two by minus 3. Minus 6B divided by minus 3 is going to give us 2B. And plus 3 divided by minus 3 is going to give us minus 1. And this is equal to 0. Now we collect the factors. We have 2B minus 3 multiplied by 2B minus 1 is equal to 0. From here, we have that either 2B minus 3 is equal to 0 or 2B minus 1 is equal to 0. From this equation, we have that 2B is equal to 3 and B is equal to 3 over 2. Or from this, we have that 2B is equal to 1 and B is equal to 1 over 2. So now we have two values for B, 3/2 and 1/2. And of course, we go back to the first equation, that is a plus b is equal to 2. From this equation, we can get values for a, because of course we know that a is equal to 2 minus b. So when b is equal to 3/2, a is equal to 2 minus 3/2, which is equal to half. And when b is equal to half, a is equal to 2 minus half, which is equal to 3/2. So we have that the 2 points that satisfy these two equations are a, b, when a is half, b is 3/2. And the second point, a, b, when a is 3/2, b is half. Now, having found the values for a and b, the last thing we do is to go back to the substitutions that we made. So to calculate the values of x and y from these values of a and b, we go back to this substitution. And we have that log₃ of x is equal to a. Now, when a is half, log₃ of x is equal to half. Of course, when we have a statement like this, it simply means that 9 to the power half is equal to x. That is, 9 to the power half is equal to x. And of course, writing this in radical form, we have that x is equal to square root of 9. And since we are dealing with logarithms, we only take the positive square root. So this is equal to 3. So here we have that x is equal to 3. To calculate the value of y, we have that log₃y of 8 is equal to b. So when b is 3/2, log₃y of 8 is equal to 3/2. Once more, this simply means that y to the power 3/2 is equal to 8. That is, y to the power 3/2 is equal to 8. Now the question is, how are we going to calculate y from this equation? What do we do to make the exponent of y 1? Remember that when we have a raised to power m raised to power n, that this is equal to a raised to power m multiplied by n. So basically the question is, what are we going to multiply 3/2 by to get 1? And of course, that is the reciprocal of 3/2, because we know that 3/2 multiplied by 2/3, which is the reciprocal of this, is equal to 1. So what we are going to do is that we are going to raise both sides of this equation to power 2/3. So this is what we have. We have y raised to power 3/2 raised to power 2/3 is equal to 8 raised to power 2/3. On the left hand side, this will multiply to give us 1. And writing this in radical form is simply the cube root of 8 all squared. And we know that the cube root of 8 is 2 squared, and 2 squared is 4. So here we have that y is equal to 4. Now we do the same thing for the second point. Once more, to calculate the value of x from this value of a, we go back to this substitution. So we have log₃ of x is equal to a. Log₃ of x is equal to 3/2. And of course, from here we have that 9 to the power 3 over 2 is equal to x. Writing this in radical form, we have that x is equal to the square root of 9 cubed. Now the square root of 9 is 3, and 3 raised to power 3 is equal to 27. So here we have that the value of x when a is 3 over 2 is 27. We go on to calculate the value of y from this equation. So we have that log to base y of 8 is equal to b. And in this case, b is equal to half. So we have that log to base y of 8 is equal to half. Once more, this simply means that y to the power 1 over 2 is equal to 8. Now, we ask ourselves the question again, to what power do we raise both sides of this equation so that the left-hand side, which is y, becomes 1? Of course, that is 2, because you know that 2 times half is 1. So we have that y to the power half squared is equal to 8 squared. And from here, we have that y is equal to 8 squared is 64. We have that this value of y is equal to 64. So we have that the 2 points that satisfy these two equations simultaneously are x equal to 3 and y equal to 4, and x equal to 27 and y equal to 64. Our task for today is to find the value of AB, given that log to base 8 of a plus log to base 4 of b squared is equal to 5, and log to base 8 of b plus log to base 4 of a squared is equal to 7. First of all, let us remember the law of logarithm that says that log A plus log B is equal to log A multiplied by B. Now, seeing this and looking at these two equations, we know that we will get a term in AB by adding this equation to this equation. So we have that log to base 8 of A plus log to base 8 of B plus log to base 4 of B squared plus log to base 4 of A squared is equal to 12. We can combine these two quantities since they are in the same base, and we can combine these two quantities since they are in the same base to get, according to this law, that log to base 8 of A multiplied by B plus log to base 4 of A squared multiplied by B squared is equal to 12. Let us remember another law of logarithm that says that log m raised to power p is equal to p multiplied by log m. And then let us look at this quantity. So we know that this quantity, which can be written as log to base 4 of a multiplied by b squared, is the same as 2 times log to base 4 of a multiplied by b. So we can write this whole line as log to base 8 of a b plus 2 times log to base 4 of a b is equal to 12. Having gotten to this point, it will be best for us to work in the same base. And then we must remember that log to base a of b is the same as log to base x of b divided by log to base x of a. So the question here is, what is the best base for us to work in? We have base 8 here and we have base 4 here. We know that these are multiples of 2. So it will be best for us to work in base 2. So we have that converting this quantity to base 2, we have that log to base 2 of AB divided by log to base 2 of 8 plus log to base 2 of 2 has to be here because of this 2. AB divided by log to base 2 of 4 is equal to 12. Now, we can simplify this quantity and we can simplify this quantity because we know that if log to base 2 of 8 is equal to y, then 2 raised to power y is equal to 8. That is, 2 raised to power y is equal to 8. And of course, we know that 8 is 2 raised to power 3. So since we have 2 here and we have 2 here, that means y is equal to 3. So we can replace this whole quantity by 3. This is equal to 3. In the same vein, if log to base 2 of 4 is equal to x, then we simply have that 2 raised to power x is equal to 4. That is, 2 raised to power x is equal to 4. And of course, we know that 4 is 2 raised to power 2. Since we have 2 here and we have 2 here, we know that x is equal to 2. So we can replace this quantity with 2, giving us that log to base 2 of AB divided by 3 plus 2 times log to base 2 of AB divided by 2 is equal to 12. We have two fractions. We need to combine them into one single unit, and we know how we do that. We multiply this quantity by this quantity. We write the plus. We multiply this quantity by this quantity. We draw the line. We multiply this quantity by this quantity. So what we have is 2 times this is 2 log to base 2 AB plus 3 times this is 6 log to base 2 AB divided by 3 times 2 is 6 is equal to 12. To get rid of this 6, we must multiply both sides of this equation by 6. So we have that 2 log to base 2 of AB plus 6 log to base 2 of AB is equal to 12 times 6, which is 72. Now we have log to base 2 of AB here, and we have log to base 2 of AB here, so we can factorize that out, which means that we have log to base 2 of AB into 2 plus 6 is equal to 72. This is simply 8 times log to base 2 of AB is equal to 72. So we have that 8 times log to base 2 of AB is equal to 72. So we divide both sides by 8, giving us that log to base 2 of AB is equal to 9. Once more, to find the value of AB, we have that 2 raised to power 9 is equal to AB. That is, 2 raised to power 9 is equal to AB. And that's our answer. You can leave it in this form or you can evaluate it. Our task for today is to solve this long logarithmic equation for x. On looking at this equation, you will notice that we also have x, the unknown, in the base of the logarithms. So the first step to solving this equation would be to change the base using our change of base formula. Now that formula says that if we have a logarithm to base a of a number b, that this is equal to log to base n, where n is the new base of the number b, divided by log to base n of the old base a. In doing this, we have changed from base a to base n. But back to the equation we have at hand. The question now becomes, what is the best base for us to change to? Now you can see that this is 4x. 4 is 2 raised to power 2. This is 16x. 16 is 2 raised to power 4. And this is half x. Half is equal to 2 raised to power minus 1. So I think that it would be best for us to work in base 2. So applying the change of base formula to this equation, we have that 40 times log to base 2. Now remember that we can write square root of x as x raised to power half divided by log to base 2 of 4x minus 14 times log to base 2 of x raised to power 3 divided by log to base 2 of 16x. Now let us bring this term over to the left hand side. So we have plus log to base 2 of x squared divided by log to base 2 of half x, and everything is equal to 0. Next, to simplify this expression, let us apply the power law of logarithms. That law states that log m raised to power n is equal to n multiplied by log n. Applying this law, we have that we can bring down this half to multiply, and you know that half times 40 is 20. So we have 20 times log to base 2 of x divided by log to base 2 of 4x minus 3 times 14 is 42. So we have 42 times log to base 2 of x divided by log to base 2 of 16x and plus 2 times log to base 2 of x divided by log to base 2 of half x, and everything is equal to 0. Now when you look closely at these three terms, you can see that we have a common factor because we have log to base 2 of x, log to base 2 of x, log to base 2 of x. And not only that, this is 20, 42, and 2. The three numbers are even, so they are divisible by 2. So that means that we can factorize 2 times log to base 2 of x, and we have 10 over log to base 2 of 4x minus 21 over log to base 2 of 16x plus 1 over log to base 2 of half x is equal to 0. Now when you look at this line, you will see that we are multiplying two things. We are multiplying 2 times log to base 2 of x into this term, and we are getting a product of 0. So that simply means that either this is equal to 0 or this is equal to 0. So we have from this statement that 2 times log to base 2 of x is equal to 0, from where we have that dividing both sides by 2, log to base 2 of x is equal to 0. So at this point, we have already found one of the roots of this equation, which is that log to base 2 of x is equal to 0. So keep this in mind. What we now do is to go on to solve this part of the equation. The next step to solving this equation is to further simplify this expression by using the product law of logarithms. We know that when we have log A multiplied by B, that this is equal to log A plus log B. And Here we have 4 multiplying x. We have 16 multiplying x. And we have half multiplying x. So we can write this out as 10 over log₂ of 4 plus log₂ of x minus 21 over log₂ of 16 plus log₂ of x plus 1 over log₂ of half plus log₂ of x is equal to 0. Now this can be written as 10 over log₂ of 2 squared, because 4 is 2 squared, plus log₂ of x minus 21 over log₂ of 2 raised to power 4 plus log₂ of x plus 1 over log₂ of 2 raised to power minus 1 plus log₂ of x is equal to 0. Now, once more, applying the power law to this, you can see that we can write this as 10 over 2 times log₂ of 2 plus log₂ of x minus 21 over 4 times log₂ of 2 plus log₂ of x plus 1 over minus 1 times log₂ of 2 plus log₂ of x, and everything still remains equal to 0. Now, having expressed it in this form and recalling that log₂ of a is equal to 1, we have that 2 times 1 is 2. 4 times 1 is 4, and minus 1 times 1 is minus 1. So we can now write this as 10 over 2 plus log₂ of x minus 21 over 4 plus log₂ of x plus 1 over log₂ of x minus 1, and everything still remains equal to 0. Now, let log₂ of x be equal to y. So from this last line, what we have is that 10 over y plus 2 minus 21 over y plus 4 plus 1 over y minus 1 is equal to 0. So now this is the equation we have to solve to get values of y and hence values of log₂ of x. Now, to solve this equation, we need to combine these 3 fractions into one single unit, and this is how we do it. We have 10 into y plus 4 multiplied by y minus 1 minus 21 into y plus 2 multiplied by y minus 1 plus 1 into y plus 2 multiplied by y plus 4. Everything divided by the product of this and this and this, which is y plus 2, y plus 4, and y minus 1. Of course, everything is equal to 0. Now, to solve this equation and find the values for which this is equal to 0, what we have to do is to solve the numerator. Expanding the numerator, what we have is 10 into, this is y squared minus y plus 4y minus 4 minus 21 into y squared minus y plus 2y minus 2 plus y squared plus 4y plus 2y plus 8, and everything is equal to 0. Collecting like terms, we have 10 into y squared minus 4, or rather minus y plus 4y is plus 3y minus 4 minus 21 into y squared minus y plus 2y is plus y minus 2 plus we have y squared plus 4y plus 2y is plus 6y plus 8 is equal to 0. Now multiplying by the coefficients, what we have is 10y squared plus 30y minus 40 minus 21y squared minus 21y plus 42 plus y squared plus 6y plus 8 is equal to 0. Now collecting like terms, we have 10y squared minus 21y squared, that is minus 11y squared, then plus y squared, that is minus 10y squared. We have 30y minus 21y, that is 9y, plus 6y, that is plus 15y. We have minus 40 plus 42, that is plus 2, plus 8, that is 10, is equal to 0. Now we can divide everything by minus 5. When we divide this by minus 5, we have 2y squared minus 3y minus 2 is equal to 0. Now we can factorize this quadratic equation because we know that the factors of 2y squared are y and 2y, because y times 2y will give you 2y squared. And the factors of minus 2 are minus 2 and 1. Now let us check for the middle term. Y times 1 is y, and y, or rather minus 2 times 2y is minus 4y, and minus 4y plus y will give you minus 3y. So that simply tells us that the factors of this quadratic equation are y minus 2 and 2y plus 1. And of course, this is equal to 0. Now, from this equation, we have that y is equal to 2, or 2y is equal to minus 1, and hence y is equal to minus half. But let us not forget that y is only standing in place for log₂x. So this means that log₂x is equal to, remember that we already got 0 as a root of that equation. 0, 2, or minus half. Now we have that log is equal to 0, 2, or minus half. From this statement, we know that x is equal to 2 raised to power 0, or 2 raised to power 2, or 2 raised to power minus half. Hence, we find that the values of x that satisfy this equation are x equal to 1, because 2 raised to power 0 is 1, or 4. or 1 over square root of 2. So these are the values of x that satisfy this equation. Now, on looking at this equation, you will see that we have log₂ different bases. The first step to solving this equation will be to make sure that we are working in the same base. Now we have log₂ base √2, log₂ base 2, log₂ base 4, and log₂ base 8. Now all these numbers are powers of 2. So the most logical thing for us to do is to change everything to base 2. We use the change of base formula. Now to change this to base 2, what we do is we have log₂ base 2 of the number, that is root x, divided by log₂ base 2 of the base, that is √2, plus this is already in base 2, so we leave it as it is. So we have log₂ base 2 of x. Next, to change this to base 2, what we do is log₂ base 2 of the number and its x squared divided by log₂ base 2 of the base, which is 4. Likewise, in this case, we have log₂ base 2 of the number, which is x cubed, divided by log₂ base 2 of the base, which is 8. And everything is equal to 40. Now we know that we can express this as log₂ base 2 of x raised to power half. And same as here, we have log₂ base 2 of 2 raised to power half. We have log₂ base 2 of x. Here we have plus log₂ base 2 of x squared divided by log₂ base 2 of 2 squared, because 4 is 2 squared, so we have 2 squared, plus log₂ base 2 of x cubed divided by log₂ base 2 of 2 cubed, because 8 is 2 cubed, and everything still remains equal to 40. Now let us recall our power law of logarithms, which says that log m raised to power n is simply equal to n multiplied by log n. So with this in mind, we have that this line can be written as half log₂ base 2x divided by half log₂ base 2 plus log₂ base 2 of x plus 2 times log₂ base 2 of x divided by 2 times log₂ base 2 of 2 plus 3 times log₂ base 2 of x divided by 3 times log₂ base 2 of 2, and everything is equal to 40. Now half divided by half is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. Then let us also remember that log₂ base a of a is equal to 1. So that means that log₂ base 2 of 2 is 1. Log₂ base 2 of 2 is 1. Log₂ base 2 of 2 is 1. So this line is simply equal to log₂ base 2 of x plus log₂ base 2 of x plus log₂ base 2 of x plus log₂ base 2 of x, and everything is equal to 40. Now how many of them do we have? We have 1, 2, 3, and 4. So we have 4 times log₂ base 2 of x is equal to 40. We divide both sides by 4, and we have that log₂ base 2 of x is equal to 10. And we know that this statement simply means that 2 raised to power 10 is equal to x. That is, 2 raised to power 10 is equal to x. And that is the value of x that satisfies the given equation. Our task for today is to find the value of log to base 2 of x over y squared, given that log to base 2 of x is equal to log to base y of 16 and x times y is equal to 64. Now we will start by deconstructing this statement. Recall the law of logarithm that says that log to base 2 of x over y is equal to log to base 2 of x minus log to base 2 of y. So that means we can replace this statement with the statement log to base 2 of x minus log to base 2 of y squared. Now, for simplicity of understanding, let us make log to base 2 of x, let us call it a, and log to base 2 of y, let us call it b. So this now becomes a minus b squared. If we expand this, what we are going to get is a squared minus 2 times a times b plus b squared. That is a squared plus b squared minus 2ab. But let us look at the expansion for a plus b squared. And this is a squared plus 2 times a times b plus b squared. That is a squared plus b squared plus 2ab. If we take 2ab over to the left-hand side of the equation, what we will have is a plus b squared minus 2ab is equal to a squared plus b squared. Now let us replace a plus b squared with this statement. That is a plus b all squared minus 2ab in the first expansion. So what we have here is a plus b squared minus 2ab, and then we bring down the 2ab that we already have, that is minus 2ab. So ultimately we have that a minus b squared is equal to a plus b squared minus 2ab minus 2ab, that is minus 4ab. So we have a plus b and we have a times b. Now going back to the original statement, what we have is remember that a is equal to log this. So we have log to base 2 of x plus log to base 2 of y squared minus 4 times log to base 2 of x multiplied by log to base 2 of y. But then let us also recall the law of logarithm that says that log to base 2 of x plus log to base 2 of y is simply equal to log to base 2 of x multiplied by y. So we can replace this with that. And this is what we have. Log to base 2 of x multiplied by y squared minus 4 times log to base 2 of x multiplied by log to base 2 of y. Now we go over to the conditions that we were given. We can see that xy is equal to 64. And then let us look at the first condition we were given. If we change this log to base y to log to base 2, what we are going to have is that log to base 2 of x, that is this, is equal to log to base 2 of 16 divided by log to base 2 of y. That is change of base. from base y to base 2. Multiplying both sides of this equation by the denominator, we have that log to base 2 of x multiplied by log to base 2 of y is equal to log to base 2 of 16. So we can replace this quantity here by log to base 2 of 16. So ultimately this becomes log to base 2 of 64 squared minus 4 times log to base 2 of 16. This is equal to that, this is equal to that, and this is equal to that. Now note that these are quantities that we can evaluate. Let us start with this one. So let log to base 2 of 64 be equal to a. That simply means that 2 raised to power a is equal to 64. Note the anti-clockwise movement. 2 raised to power a is equal to 64. That is 2 raised to power a is equal to 64. But 64 is equal to 2 raised to power 6. So you have 2 here and you have 2 here. So automatically a is equal to 6. So this is equal to 6. Likewise, let log be equal to b. Once more, that simply means that 2 raised to power b is equal to 16. That is 2 raised to power b is equal to 16. 16 is 2 raised to power 4. You have 2 here, you have 2 here. So that means that b is equal to 4. So this quantity is equal to 4. So ultimately, we have that this is equal to 6 squared minus 4 times 4. And this is 36 minus 16, and that is equal to 20. So this is equal to 20. Hello and welcome. In today's tutorial, our task is to find all the values of x that satisfy this equation. But before we can do that, for illustrative purposes, I'd like to write this equation in its exponential form. We have that 8 log x is equal to, we take this over to the right hand side and we have x. Now we divide both sides of this equation by 8 and we have that log x is equal to x over 8. Now you know that when we write log without specifying the base, it means we are working in base 10. And written as an exponent, this equation is simply 10 raised to power x over 8 is equal to x. That is 10 raised to power x over 8 is equal to x. Now you know that when we solve exponential equations, usually what we do is to manipulate the equations until we get to the form a raised to power x is equal to b, where a and b are real numbers. Then we take log of both sides and we end up with the solution x is equal to log b divided by log a. But notice that in this case, we have x, the unknown, both in the exponent and outside the exponent. So we cannot simply take log of both sides. In cases like this, where we have the unknown both within the exponent and outside the exponent, the function we use is called the Lambert W function or the product log function. But before we can apply that function, we must get this equation to look like w(e) raised to power w is equal to some real number c. That is, what you have before e must be the same thing as the exponent of e. Now let us solve this equation so that you can see what I mean. The first thing we do from here is to take the natural log of both sides. And when we do that, we have that ln 10 raised to power x over 8 is equal to ln x. Of course, you know that we can bring down this exponent to multiply. And when we do that, what we have is x over 8 times ln 10 is equal to ln x. Next, we divide both sides of this equation by x. When we do that, we have that ln 10 divided by 8 is equal to ln x divided by x. Now, you know that when x is dividing, we can write it as x raised to power minus 1. And this is multiplied by ln x. Here we have ln 10 divided by 8. Now, next, remember that when we have e raised to power ln any number m, and this is simply equal to n. So we can write this x as e raised to power ln x. And then remember the raised to power minus 1. So we have raised to power minus 1. And everything is multiplying ln x. So writing this in the proper form, we have that ln 10 divided by 8 is equal to, we have ln x multiplied by e. Remember that when you have a raised to power m raised to power n, that it's simply equal to a raised to power m times n. So to open this bracket, we multiply minus 1 by ln x. So we have e raised to power minus ln x. Now notice that we already have ln x here and we have ln x here. The only thing that is lacking here to make what we have before e look like exactly what we have in the exponent is this negative sign. And how do we introduce that negative sign? By multiplying both sides of this equation by minus 1. So when we multiply both sides of this equation by minus 1, we have that minus ln x e raised to power minus ln x is equal to minus ln 10 divided by 8. Now, notice that what you have here is exactly the same as what you have in the exponent of e. So now we can comfortably apply the Lambert-W function to both sides of this equation. But before we do that, we need to use our calculator to evaluate this. And when we do that, we have that minus ln 10 divided by 8 is equal to minus 0.2878. Now, when you apply the Lambert-W function to this, what you simply have is this. So you have that minus ln x is equal to, we apply the Lambert-W function to this also. We have Lambert-W function calculators online that you can use. What you simply do is to plug this number into the calculator. Now, when this number lies between the range minus 1 over e and 0, the Lambert-W function calculator will return two numbers. In this case, we have that minus ln x is equal to minus 1.8731 or minus 0.525. Now, of course, we have negative here and we have negative here, so they can cancel, giving us that ln x is equal to either 1.8731 or 0.4525. And of course, you know how to solve this equation. You know that when you have ln x is equal to a number, it simply means that x is equal to e raised to power 1.8731 or e raised to power 0.4525. And when we evaluate this with a calculator, we have that x is equal to 6.507 or 1.572. So the two values of x that satisfy this equation are 6.507 or 1.572. And with that, we come to the end of today's exercise. Remember to subscribe if you enjoy such content. Leave us a thumbs up to support the channel, and see you in the next one.